Okay, so let's try to solve this problem palindrome partitioning. Okay, so it is said that given a string S, partition S such that every substring of the partition is a palindrome. Return all possible palindromic partitions of S. Okay, example, S is equal to AAB and what will be the results? AAB, AA and B. Okay, similar for example 2, it's A. And what are the constant has been mentioned? The string length maximum can be 16th. Okay. Okay, so what is the intuition behind this problem? So intuition is like we need to generate all palindromic combination of substrings, right? And to do this, what I need to do, we need to partition at every index, right? Need to partition at in every index and generate all the substrings, right? So once we generate all the substring, then we can see like whether it is palindrome or not, and then that combination we can put into our result set, right? And when we see this kind of keywords, right, generate all and then generate all, so which approach we can take? We can take recursion, right? And then we got a case of combination, so in that case we can think of backtracking. Okay, another hint this problem gives is n is less than equal to 16, so the string length is less than equal to 16 and greater than equal to 1, and this is a very small number, so we can think of having a brute force approach, or we can have backtracking, or we can have 2 to the power n solution, or an n factorial solution. Okay, so let's try to take an example and draw the recursion tree first. Okay, so recursion tree, we'll take an example of AAB. Okay, so first we'll partition at the first index, so this will be the result. Okay, we'll decide, right, we'll backtrack, we'll not partition at the first index, we'll partition at the second index, so then AAB. Okay, and then we'll decide, okay, we will backtrack, we will not partition over here, we will not partition over here, we will partition over at the last index, but last index is the end of the string, so you cannot put the partition over here. Okay, then okay, so now we have this one, so we already had a partition over here, so we'll put a partition on the second after the second character. Okay, and then this is the result. Okay, and then we'll backtrack, we decided we'll not put the partition over here, then what will be the result? Okay, we'll put the partition over here, but this is the end of the string, so you can simply remove. Okay, then over here, right, for this it is a again you can take this, and then we'll decide like we'll put the partition at the end. Okay, but this is the end of the string, so you can put the partition over here. Okay, then again we'll take this one. Okay, we'll have AAB, and then we'll put a partition over here, but we cannot put a partition over here because it is end of the string. Okay, so over here we got this one, we got this one. Okay, so this A itself is a palindrome of its own, AAB, so this is one subset we can get. Okay, and then this is combination we can get, and then this is another combination, AAB. So in the final result, what will be the result? Will be AAB, so this is one, and AAB. Okay, so this will be the result then. Now how to approach to this problem? Okay, So first we can have a function to generate all the substrings beginning at index start. Okay, next, for each of the substring we can check whether it's a palindrome or not, right? If it's a palindrome, then we can push or append to a list into a list if the current string or the substring current substring ended at index end, then we can call the same function recursively with n plus 1, right? N plus 1. Okay, and third point is backtrack if the start index reach the end of the string. Backtrack if the start index reach the end of the string. Okay, and now while coming back, right, while coming back we can push the current list to the result set. Okay, so we have discussed the approach. Now let's try to code this. We'll first declare a variable to store the string length. Okay. Next we'll declare a result array to return the results. Okay, okay, and then over here we'll declare a function dfs which will take start, which will take current list. Okay, and it will also take the string as well. Okay, over here what will be the base case? Base case would be if start equal to let's declare a length over here only. Okay, variable to declare the length. Okay, so then start equal to if start equal to 10, then I can simply if the start equal to n, then all I need to do, we need to pass the result as well. Result, so result dot push current list. Okay. Submit it over here. Okay, so if the start equal to, then we can return. So this is the base case. Okay, next we need to iterate, right? So we need to iterate, we need to generate all the substrings. So let end equal to start, end less than end plus plus. Okay, and then we need to create the substring, but before creating the substring we need to check whether it's a palindrome or not. So you can define a function is palindrome function start, end and s. Okay, we'll come to this function later, but as of now let's write the code. If is palindrome, and then pass start comma end. Okay, and pass the string and give it a palindrome. Then we have to have the substring and push into the current list. Okay, so basically then the current list dot push is dot substring start comma n plus 1. Okay, then what we need to do, we need to call this dfs function. Okay, and the parameter will be n plus 1, so we need to go depth. Okay, I need to partition more. Okay, so n plus 1, and then what will be the card list? So this will be the card list s comma result. Okay, this is done. So this is the include case, so we have included the current substring, but while backtrack we need to exclude also, right? So then what we need to do, we need to simply pop it. Okay, and then so this is done. Then what we need to do, so let's call the dfs function. We have done everything and start on, so backtrack, this is the backtrack one, exclude case. Okay, so start equal to n, string outputs return, n equal to start, n less than n is palindrome. Okay, so let's define the function over here as well. Okay, so I'll start less than equal to end if s of start not equal to s of end. And then what you can do, you can simply return false, increment the start and increment the end. So we've created, we've taken 2 pointers which are moving towards each other. Okay, then we can, if it is it will be true. Okay, so if it's a palindrome, then it will be true. Okay, and then over here what we need to do, we need to call the dfs function. Card list is then result, this result, return result. Okay, Let's see if we are doing good. Okay, it gave once again. Okay, so this is fine. This is fine. Okay, my bad. To slice it, I need to create a new object. Okay, so this is fine. Now let's try to run. Awesome, it's running now. Okay. Okay, so let's try to discuss the time complexity of the solution. Okay, so we had taken a string of length 3, right? And if we had if the length is 3, then how many states we could have? 1 2 3 4 5 6 7 8. So 8 states, which we can say as 2 to the power 3 states. Okay, so then time complexity becomes 2 to the power n, right? Okay, next we are running a palindrome function, like whether it's a palindrome. So if the, let's say if the string is like AAA, in that case what will be the time complexity? O of n. Okay, another thing, we are also calculating, we are also creating substring like each step, right? So let's say we are creating substring from 0 to 3, so in that case also it will be n, right? So it is 2 to the power n into n. Okay, this is the overall time complexity, so which we can say that it's 2 to the power n only. Okay, exponential. Okay, and what will be the space complexity? Space complexities, we had the string of length 3. Now how many level we are going? Okay, so this is 1 2 3. Okay, so from 3 steps we are going, right? So in that case it will be O of n. Okay, which is the recursive call stack space. So we had the time complexity of 2 to the power n into n plus n, where n was the to check the palindrome, to check the palindrome, and another was to create the substring. Now can we improve this? Okay, I think we can. Okay, let's take an example. A C B C A. Okay, and this is start, this is end. Okay, here S of start is equal to S of end. Okay, right? So this is same. Okay, now the string, which the substring which started from start plus 1 and ended with n minus 1. So this particular part, this is palindrome, this is palindrome. Okay, if this is palindrome, then entire string can be palindrome, right? Now here we are pre-calculating that this particular part is palindrome, then we are saying that the entire substring is palindrome. Okay, so if there is a pre-computation, then which approach we can think of? We can think of dynamic programming. Okay, so for the dynamic programming, we can take a 2D array, okay, of size n, okay, and what we can do, so we the logic will be, if the logic will be dp of start end is equal to the dp of s of start is equal to s of end. The both the both the characters on the at the start position and end position should be same, and dp of start plus 1 and end minus 1 needs to be true. Based on that, this particular the substring which started with start and ended with end, so that will be true. Okay, now let's have a string like this. Okay, now this particular character, this is palindrome. Okay, this is 0 1 2. Okay, now if this is palindrome, right, if this is palindrome, then this entire the string will be palindrome, like we have discussed. So in that case we can say, like, if end minus start less than or equal to 2, right, so this is end is 2, start is 0, less than or equal to 2, so 2 less than or equal to 2, then we can simply say if s of start is equal to s of end and end minus start less than or equal to 2, then we can simply say that this the string started at start and ended with end is palindrome. Okay, so then we can say, we can modify this, if dp of start end is equal to s of start equal to s of end. So both needs to be true first, both the side needs to be true, both the character on the both the side should be true, and end minus start less than or equal to 2, or dp of start plus 1 end minus 1 needs to be true, right? Okay, so let's modify the same code we submitted a little while ago. So let's first declare a 2D array, 2D dp array, dp equal to array dot from length s dot length and new array start length. Okay, and will initially fill with false. Okay, now this dp array we will pass to this dfs function, pass to this, we will pass to over here as well. Okay, now this is not required anymore. Okay, we'll delete this. Okay, similarly this also will delete, not required. Okay, so first we'll check if dp if s of start is equal to s of end and end minus start less than or equal to 2, or dp of start plus 1 end minus 1. Okay, so this is okay, and then we'll simply say dp of start end equal to true. Okay, and copy paste the same code over here. All right, this is done. DFS first. Okay, let's try to submit this. Awesome, it's passing. Okay, so What will be the time complexity? So time complexity would be same 2 to the power n exponential, but this time we removed one check for which was having like O of n complexity, right, to check the string whether it's a palindrome or not. That we almost removed, and then we still have this substring function which takes n, so that's why I've taken n over here. So 2 to the power n into n. Space complexity, it's still we are using the recursive call stack space, so it is O of n only. Okay.